Hi everyone, in this video I'm going to be working through some more questions from this paper. I hope this helps. Let me know in the comments if you have any questions. So if we look at this question, we've got study the diagram below and then reflect the object about the y-axis. Okay, so if we're reflecting it about the y, let's just label quick. So this is our y and this is our x. So if we're reflecting it about the y, they mean just mirror it over that y-axis. Okay, so all we have to do if we're going to do this is we just need to make sure we reflect each of the points. So that's how I usually go about it. So I would say, okay, this point B is here, it's 2 across and 2 up. Okay, so if I'm reflecting it across, it's just going to be, okay, I had 2 across that side, it's just going to be 2 across that side. So that is going to be your point there. The level stays the same, the height, because you're just reflecting it across the y. If you're reflecting it across the x, you would move it down. Same for the a. So a was 4 across. So I'm just going to go this side and go 4 across. Okay, so that's going to be your new a point. And then c was 4 across. And again, it's going to be 4 across, but at the same height. When we label these then, if I just get a different color, so B, when we mirror something or reflect it or translate it, we just put a little apostrophe next to it to show that it's been moved. It's not the original point. And then we just connect the dots. Okay, yours will probably be straighter because you'll have a ruler. So it's going to look something like that. So that is how we reflect something across. So you just imagine you putting a mirror on the y-axis and then you're mirroring it across. If we look at then the next question, write the rule that you used to reflect this in this form. Okay, so we just need to see what happened, what did we do to the x points, what did we do to the y points. So this is actually a pretty cool rule. It's a quite a useful one to remember. So if you are reflecting across the y, okay, so if I'm like we did here, we reflected across the y, then the y stays the same, but your x just changes sign. And it's the same. So if you reflect across the x, then the x stays the same, but the y, the sign changes. So here what happened was we said the x stays the same. So let's get a different color. Our x stays the same. No, sorry, our x doesn't stay the same. Our y stays the same. So our y stays the same, but our x becomes negative x. So whatever we had, we flip it over, which feels funny because we had negative 4, but then if we times that by negative, that's why it becomes positive 4. Okay, so all of our x values here change signs, so that's why we put that negative in to change the sign. If we look then at question 8, we have got a circle question here, and I think also a Pythagoras question. Okay, so if we look at this question, they say triangle ABC is inscribed in the circle below. AC is 5 centimeters, so this line is 5 centimeters. BC is 4 centimeters. And then AC is the diameter of the circle. Okay, so we can say somewhere there is the center of the circle. So diameter of the circle means it stretches all the way across the circle and it passes through the middle. They want us to calculate the length of AB, so they want this length. Okay, I'm just going to call it x. So if we need to calculate the length of an unknown side in a triangle, and it's a right angle triangle like this, you'll go to what you should be thinking about is Pythagoras. Okay, so for this 8.1.1, we are going to be thinking about Pythagoras, and probably get a mark just for writing down the Pythagoras rule. So Pythagoras is always, I try to remember it as the hypotenuse, so the longest side of the triangle squared is equal to the other sides of the triangle, like this. Okay, sorry, that's B. Okay, so what we can say here, we have the longest side of the triangle is this one. Okay, so we can say 5 squared. The reason we know that's the longest is the longest side is always opposite that right angle. Okay, so 5 squared is equal to 4 squared, doesn't matter what order you do this in, plus x squared. We can then work this out. So what I would do is I'd take that 4 squared across. So I'd say 5 squared minus the 4 squared is equal to x squared. Okay, if we work that out, 5 squared is 25, 4 squared is 16, is equal to x squared. Let's work this out. 25 take away 16 is going to be 9. So 9 is equal to x squared. And if we want to get rid of that x squared, we just want x by itself. We square root both sides. And so we're going to get x is equal to 3. Okay, so we find that that missing side, that length there, is 3. So I went through the whole thing because a lot of times they do ask you to do that. But what you can also try to remember is there is actually a hack for triangles like this. So if you have a triangle like this, and you know one of the sides is 3, one of the sides is 4, the other side is 5. So if you know two of the sides, it's called a 3, 4, 5 triangle. So if you know you've got a 3 and a 4, the other side has to be a 5. Or if you know you've got a 4 and a 5, the other side has to be a 3. So we could have just immediately said that that side is 3. But it's good to check that we know the Pythagoras as well. Okay, next up, calculate the area of triangle ABC and then the area of the circle. So I don't think I have enough space here, so I'm going to just scroll down to the bottom. Okay, so let's just do a quick drawing of this again. So we had the circle, we've got this triangle in the middle, obviously not exactly drawn right, but anyway, so we said it was a 3, 4, 5 triangle, and then that is our diameter, so our diameter is 5. And they tell us that we need to use pi is 3.14 centimeters. No, 3.14, just 3.14, sorry. Okay, so first of all, let's work out the area of the triangle. Okay, so again, this is going to be something that you get a mark for knowing this formula. So let's work it out here. So the area of any triangle is always a half times the base of the triangle times the height of the triangle. Okay, the base and the height is always, we want the perpendicular height, so we want what is attached to that perpendicular angle. If we just go back to it, because my drawing's really not great, we can see our height and our base, they're the two things that are connected to that perpendicular angle here, okay, the 90 degree. So we've got 3 and 4. Okay, so we are going to say it is a half times 3 times 4, actually the other way around, but it doesn't matter, we're going to be timesing. And so if we work this out, 3 times 4 is 12, and half of a 12 is 6. And so our area of this triangle is going to be 6 centimeters squared. Remember, area is always squared. Then they also want us to work out the area of the circle. Okay, again, area of the circle is going to be something that you have to remember that formula. So let's just get a different color here. Okay, area of a circle again, you would get a mark for just writing this formula. Area of a circle is always pi times your radius squared. Okay, so they told us the diameter is 5. The radius is always half of the diameter. So we've got the diameter here all the way across the circle, so the radius would just be half of that. Okay, that would be your radius. So we would say a radius is half of 5. We have a calculator, but lots of people know this one anyway. So half of 5 is 2.5 centimeters. Then what we have to do is we're just going to say they told us to use pi, we have to use 3.14. Our radius is 2.5 and we have to square that. Okay, you would just plug that into your calculator. Let's have a look at what this is. If your calculator doesn't do the square thing, you could also just say 2.5 times 2.5 and then times 3.14 and we get 19.625. then they tell us right at the beginning of this paper, and it usually is the case, round to 2 decimals, so 19.63, and again, centimeters squared because it is area. Okay, so there we've worked out the area of the circle and then the area of the triangle. Let's see what we need to do next. Okay, and then they say hence calculate the shaded area. So they love asking questions like this. So they usually get you to work out the full circle, then the full triangle, and then to work out the difference between them. Okay, so if we want the shaded area, what we have to do is we have to go the circle, take away that triangle. Okay, which is why they asked us to work out the 2 parts. Okay, so I'm just going to work it out. I'm going to work it out at the bottom again. So the shaded area, let's work it out here. Okay, so this is something to keep in mind because they really like asking this. So in this case, we worked out the full circle, and then we're going to take away the triangle to get the shaded area. So we said the circle was 19.63, the triangle was 6, and so we can just work that out. So 19 take away 6 is going to be 13.63, and it's still an area, so centimeters squared. Okay, then next up we have a volume question. So they ask us then, they say determine the volume of the cylinder if it has the following, of a cylinder if it has the following dimensions. Okay, so a cylinder, we know it looks like a toilet roll. Okay, so something like that. The radius they say, so that is the radius, half of that circle there, and then the height is 20. So height is 20 centimeters, and then the radius, let's just get a different color for that, is 7. Okay, the important thing with volume, so the volume, how I like to remember volume, is the volume of any 3D shape is the area of the base, so the area of the bottom or the top, the area of the base, and then times the height. Okay, which is quite a nice way of remembering because some of these formulas get quite crazy. So in this case, we have the area of the base, so the base is a circle. So we're going to say the area of the circle and then times it by the height. Okay, so we already have to remember the area of the circle. So area of the circle, we said, is pi times the radius squared. So pi times the radius. In this case, they have given us the radius, which is quite nice. So pi times the radius squared times the height. We just got to plug these values in. So pi is 3.14. The radius is 7 squared, and then the height is 20. So we just put that into our calculator, and they tell us to round it to 1 decimal place. So let's see. So we're going to go 7 times 7 is 49, times 20 times 3.14, and we're going to get 3077.2 centimeters. Volume is a 3D shape, so it has a 3. Okay, so nice and straightforward there. The important thing is trying to remember this volume formula because that is brought up a lot and it's a really nice way of remembering the volume of any shape. So you just work out area of the base and then you times it by how tall the shape is. Okay, I think I'm going to end this live there, but please let me know if you have any questions or any comments, and I'll keep working through this in another video. Thank you for watching.